Hello and welcome to the screencast. My name is Joff and this is test-driven development on Android. Now I just happened to plug this entire thing into an Android context, but the things and the practices that I'm demonstrating in these three screencasts are language agnostic and platform agnostic, so I'm sure that they're going to be applicable on whatever you are working on. So this is the first episode of the Chicago School, or so-called inside out test-driven development approach. And the idea is to make us able to make a comparison between the two test-driven development styles. As you know, if you don't know, on my YouTube channel there is an available series of demonstrating outside-in test-driven development, where I'm working throughout the search functionality and the idea of the outside in. When I say outside in or inside out, I am referring to the way of designing the software. So with the outside in approach, we are beginning to develop the whole thing from the outside of the system. So we focus on the things that we are going to pass into the system and the things that are coming out. So we are starting from the outside, and then we are designing the entire solution from outside towards the inside. However, with the inside out, we are starting from the essential of the thing, from the very algorithm, and then we are building on top. And the idea of this series of screencasts is to demonstrate how that's gonna look and how we are gonna go through that. So before we start with the whole thing, um, here, as I said, we are going to work on the same exercise, and the idea is that we want to be able to make a search based on a query. So we are having a query, and then we are going to make a search. So what is a good practice that I find useful whenever I'm starting to work on something is to write down some, like, a few things that I can think of at that moment, few things that are important, that I simply care about for what I'm gonna build. So in the terms of the search, for example, the things that I'm gonna start off with is, let's say, I'll care about the behavior when I find a match. So for example, find a match. And then another interesting thing would be if I don't find a match. So a match not found. And let's make that presentation, make it bigger. And then the last thing that I'm thinking right now is, let's say, a bad query. So the idea is that, like, I just want to start from somewhere, and what I'm thinking right now is that these few things are just something that I would definitely start to work on, and as I'll go through the entire solution afterwards. I'll definitely find another things that they'll just pop out from whatever I'm gonna be doing, and then I'm gonna write them down here in this list. And the idea is that I just want to have something to refer to, like where to see where I am and how to proceed. So these are just the three things that I can start off with, and of course I'm gonna start with a test. So now I'm thinking, instead of trying to I just want to start very simple. So I'm just gonna have a query, and then I'm gonna find a match. I want to start with something with very simple. Like, instead of returning, like, I don't know, list of items that I'll find, or list of matches, I'm just gonna start with a single thing. So it's gonna be easier for me to build on top of that afterwards. Um, I'm just thinking of what is the simplest thing. So let's say how would we name this? I don't want to, unlike the outside in approach, where we were naming the tests and the test cases with a should, and then the test would start with a verb. here I wanna test. I wanna name the things according to the behavior they're gonna be checking. For example, here I'll start with something like, let's say, find one match test. Something like that. Let's close this panel on the left, then start off with a test. So the first thing that we wrote here is like find a match. So let's start off with that one. For example, match found. I struggle to name these things because, like, what are the things that are coming back from a search? I'm performing a search. What is the result? How do you name the result? Are they values? Are they matches? So I'm struggling to find the right word. So I'm gonna stick to matches for now. Assert equals. So I would say something like, let's say, item one, and then now I'm thinking about where to start off. So if you remember, if you haven't seen the Outside In TDD series, please go ahead and look. But the thing is that in Android, we are having, the idea is to have the UI layer completely detached from everything, and then have a responsibility only to render states. And then the UI would send events somewhere and observe states from somewhere. So that somewhere is sort of a boundary that the UI is talking to. And I'm just thinking to have the same thing here. So I'll have something like, let's say, a searcher, and I'm just gonna write for now simple query function get result. And of course, this is gonna be, it would evolve. I'm just thinking right now that it would evolve to something that the UI will be able to observe. But for now, I can just go very simple, like whatever comes to the simplest things that are coming to my mind. I'm just gonna try to project here. And the searcher would be a, let's say, searcher, and then I need a trigger. So I would say a searcher dot search item. I want a relation between. So I'm searching an item. I should get item one. And now, of course, I don't have this searcher. Let's create a class, and I'll extract it into a separate file. But instead of having it in the tests, I'm gonna create it in the source directly. And I'll move it on the right so we can see both things at the same time. Of course, now I don't have the search. Let's create it. And then I need this query function here. So it's gonna be a string. And in fact, let's make it return a null. So now our test is compiling. I think we can go ahead and run it and see. So we need to watch it fail. So that's sort of the very beginning. That's where I'm thinking to start off with, and see how we're gonna proceed forward. It takes probably a little bit time when I run for the very first time. That's significant time. Maybe I should have warmed this up before, before starting. Yeah, there we go. And now I have a failing test. And indeed, it says, I'm expecting item one, I receive null. So now, one of the differences between the inside out and the outside in is that in inside out, in what we are doing right now, we have to go from red to green as fast as possible. So we have to do whatever comes to mind. Like, we can just use, hard coding values, copying stuff and things like that just to make the things pass. And only afterwards, we are going to focus on making the code right. So the simplest thing to make this thing pass now is to just hard code item 1 here and then run. And hopefully this time it's going to run faster, of course. Now I have a passing test. And I think it's wise to check this in. So for this exercise, I've created a new branch in the same repo. It is called search classicist. So you can go ahead and find it out. I'm gonna make sure to put link in the description of the video so you can find it, so you can follow the entire process there. So let's say can find a match a hard coded. So the idea is that I want to make these commits seem like I want to break the assumptions that I have when I'm making this commit. When I have something like passing test, I want to in the following test, in the following iteration, I want to break those assumptions that I have. So for example, now I'm having assumption that all items in the world, all values in the world are gonna be item 1, and then when I say query, it's gonna return. So if all the values are item 1, I'm done here. But of course, not all the values gonna be, not all matches, I would say. Well, values, because I can have different values, and the match is an item. If it's item 1, then of course that's not gonna happen. I'm gonna have multiple of them. So how do I now proceed? How do I how do I start evolving this algorithm? So one thing that we can start off with, and it works always, is called triangulation. So essentially, I'm gonna write a new test that's gonna say, let's say, another match found, and then here I'm gonna expect, say, another another item, searcher, get result. And again, I'll create a searcher here. And again, I'm gonna do a searcher, search, and now I have to ask for, let's say, another. Run the tests. It would fail, right? And essentially it fails for the right reason. I'm expecting another item, it returns item 1. Now the idea is that how do I make this work? So one way of doing this thing is like to make the input closer to the output. So for example, here in the searcher, the input is the query and the output is the item. So how about, how can I make this closer together? How can I make like, the idea is to, by making them close to each other, is like the input should dictate the output. So first of all, I would disable this test because I don't want to refactor in a red state. Now I have a failing test, so maybe I can comment this out, or it would be better if I just disable it. A factoring here. Let's run to make sure this is disabled, and I'm still green. Yep. And now what I can do, I can extract a field out of this one. Actually, in Kotlin, it is property. I'm going to make it var because I want to be able to manipulate it. So the idea is to set the value based on the query. I'll name it, let's say, result. Let's see what it does. Yeah, so I want this line to happen here. And now if I run, it should be still green. Cool. And essentially here I have to specify the type, and I'll by default set this to null. And run again. It should still green. Cool. Now let's maybe first check this in. And I would say something like moved the output closer to the input. Cool. And now I can enable back this test and run and watch it fail. Now it should fail for this reason. Exactly. And how to make this pass now is I'll copy this. And here I would say if the query is item, then give me this. Else if the query is another, then the result is going to be this. Now let's see if they're gonna work. Cool. Let's check this in. Can find at least two different values. Cool. Now if we go back here, I think I can cross this one. And now I can focus on the what if I find no matches. I think I'm already sensing where this is gonna go. But like, whenever you are not like entirely sure, the best thing you can do is to get more evidence. And like, how do you get more evidence is by, of course, writing more tests. So let's go ahead and create new test. And this time I'll say no value, no match found. I would say something like no match found for, let's say, coffee. Oops. And then I'll say searcher dot get the result. And the searcher is again searcher. Now let's say searcher search coffee. That's gonna be my test. Run and watch it fail. And it says no match found for coffee, but the result is null. How do I make this pass? Is I would say else result is this. And now run. Cool. Let's check this in. Can handle value not found or I would say specific query. Specific because it's just one query that I can handle results from. And now, how can I generalize this one? Because now, for example, the problem is that if I, for example, right here, let's say beer. Yes, I like beer. The test is still gonna pass, and that's bad. So essentially what I wrote here is I would project another test out of it, right? So I can do the same trick, the same triangulation that I used in the first with a product with another match found. Um, so I can do the same triangulation here in order uh, to see how to generalize the error handling. But um, uh, another thing actually, so by for example typing beer and then expecting no match found for beer here. Um, but there is another thing that we can do here, like in this specific case, because it just happened like that, is if we remove the duplication here, the coffee here and the coffee here, if we manage to remove that duplication, we are essentially getting the same result as if we do a triangulation. But the problem is that this is not always available. So the triangulation, as I said before, is always gonna work. In this case, we can do the remove the duplication, and what actually we can do is I can use the query here, because the query is actually what comes what I'm passing there, and it's gonna match here. So now if I run, it is still going to pass, I expect. All right, now let's check this in. I would say can handle missing match for any query. Yeah, cool. And then if I do a little defect injection here, what I've done before, and run again the tests, now this should fail. That's just gonna be a proof that, of course. So it's a proof that everything seems fine. Now we have the match not found case here, and what I'm seeing here actually, I can already sense the algorithm. Basically, the else I got, and then I can just by duplicating this thing here. That's my algorithm. So essentially, I'm having just a contains algorithm. So I'm gonna have some sort of values out there, and then I pass a query, and wherever the query is contained in the in an item, then that item would be the result. So maybe it's wise to write it here. So here, like contains, I don't know, whatever contains query. That's gonna be the algorithm. And now what's left is the bad query actually. But I'm seeing that here I'm already running over 20 minutes, and maybe it's a good idea to just stop this episode and continue in the next one, so we can see how to proceed. The idea is that I don't have I don't have a way to split the episodes into logical units as I've done with the outside in. But I hope that's not going to be a problem. The episodes are weekly, and I hope like each week I'm going to release the continuation of where we stopped. I think that's going to be fine. I'll make sure to push this now. I think I'm clean. Yeah. So let's make sure to push this. Search classicist. Yeah, and then I'll make sure to include a. So here is also the link, but I'll make sure to add the link in the description of the video. Thank you very much for the attention and for watching. If you happen to like this content, please make sure to subscribe, and I'll catch you in the following episode. Thank you.